Before we can study any branch of mathematics, we first have to study sets. So, what is a set? In simple terms, a set is a collection of well-defined objects, or things. Notice, in the definition, we use the term well-defined. That is, there should be no ambiguity when we define a set. For instance, a collection of sports cars is a set. However, a collection of good sports cars is not a set. Your definition of a good sports car might not be a good car for another person. A set is normally represented using curly braces, and the objects within the set are separated by a comma. The objects in the set are called elements. Here we say, 2 is an element of this set. So is 4, 6, and 8. We can also give a set a name. For instance, the given set could be represented by the letter P. So, wherever we see P, it represents this collection. Hence, we can now say, 2 is an element of set P. 4 is an element of set P. And so forth. Finite and infinite sets. Sets can be finite or infinite. A finite set is a set that can be counted. That is, there is a limit to the number of elements in the set. For example, a set containing all the odd numbers less than 10. A set containing all the even numbers less than 20. Here we can count the elements in both sets. Hence, both sets are finite. An infinite set is a set that goes on forever. That is, we cannot count the number of elements in the set. For example, the set containing numbers greater than 5, or the set containing numbers that are a multiple of 2. Both sets cannot be counted. And to show that the set goes on forever, we put the ellipsis at the end like this. Consider the two sets. The union of P and Q, written as, is the set containing all the elements of P and Q. The intersection of P and Q, written as, is the set containing all the elements common to both P and Q. Before we look at the next notation, let's represent P and Q using a diagram. Such a diagram is called a Venn diagram. Let's now look at the complement. The complement of a set is the set containing all the elements that are not an element of that set. For instance, P complement, written as, is the set containing all the elements which are not elements of set P. So, P complement is 6 and 7. Similarly, Q complement is the set containing all the elements which are not elements of set Q. Let's look at an example. Use the Venn diagram to determine the elements of the sets below. From the diagram, the set R contains the elements 6, 7, 8, 9, and 10. The set P contains the elements 9, 10, 11, 12, and 13. R union P is the set containing all the elements of P and Q. So this set will be 6, 7, 8, 9, 10, 11, 12, and 13. R intersect P is the set containing all the elements common to both R and P. So this set will include 9 and 10. R complement is the set that excludes all the elements of R. So this set will include 4, 5, 11, 12, and 13. P complement is the set that excludes all the elements of P. So this set will include 4, 5, 6, 7, and 8. R complement intersects P complement is the set containing all the elements common to both R complement and P complement. So this set will be 4 and 5. Set A is a subset of set B. If the elements of set A are elements of set B. Consider the following sets. Notice the elements of set A are also elements of set B. In this case, we say, set A is a subset of set B. We can also represent this using a Venn diagram as follows. In the next lesson, we will review number systems.